Afternoon, ladies. So title for today is to look at the middle and lower course landforms, and again we're going to try and look at four different landscapes today, although three of these are interconnected. So our meanders, oxbow lakes and floodplains are all linked, and then the levees form on the floodplain, so they all tie together. The objectives are written there as well, so please, once you've finished watching the video and finish with your notes, do go back and kind of try and assess how well you feel you've met those three objectives. And if you have any questions, just drop me a comment either on the YouTube video or in Google Classroom. Okay, so when we're thinking about the middle and lower course landforms, it's probably more helpful to think about it as one continuous change rather than two different kind of thirds of the river, because all of the landscapes that start to kind of form and start to be created in the middle course just continue, and those processes just become more exaggerated, so the landscapes become bigger and more obvious in the lower course. So everything we find in the middle course we would also find in the lower course. So as I say, the next couple of slides are all going to go through the different landscapes, and you can pause this video or you can use the Google Slides to make your notes today. I've tried to kind of keep it really simple, so what's on the slides is what you need to know. Our first landscape is meanders. Meanders is just a name for bends in the river. They start when the river enters lower altitude land in the middle course, and they really begin due to excess energy. This excess energy is there because there's a higher discharge, there's a smoother bed, and ultimately there's less friction. And what happens is this additional energy causes something called helicoidal flow. That's essentially the water is spiraling as it travels within the channel. And what that does is it's a bit like a corkscrew. It scrapes away at the bed of the river in some places, and it deposits that sediment in other places, and this creates what's known as pools and riffles. The pools are deeper areas and the riffles are shallower areas, as we can see in the first text box there. Over time, the river, this continues, this process, this kind of corkscrewing motion, and the water has to start flowing around the shallower riffles because this sediment creates a blockage or an obstruction, so the water flows around it. And this is what causes the river to bend. Now, over time, if we fast forward even further, this bend becomes more prominent or more pronounced, more sinuous is another word we would use for it. And the bend grows. This is because, a bit like on a running track, to keep up, the water has to flow faster on the outside and move slower on the inside. So the faster flowing water on the outside of the river, outside of the bend, meander, has much more energy, therefore it causes erosion, widening the bend, and on the inside it's much slower, causing deposition. So if we have a look at this diagram, where the arrows are, there's erosion happening, and where the white dots are, that represents deposition. So the water is flowing faster on the outside bends of the channel. And that's how our meanders are formed. So here's another kind of diagram showing that. We can see a much more, or a meander that's kind of taken longer to form, much more pronounced or sinuous bend here. The orange areas represent where there's erosion, and the yellow areas represent where there is deposition. And this is due to that faster flow on the outside, more energy, lots of hydraulic action, and slower flow on the inside, so less energy, it can't carry its load. And if we have a look at this cross profile, if we were to cut through the river channel, this is what it would look like. So the outside bend, where it's much faster, we've got this erosion and it's deeper water, and on the inside bend we've got this deposition where the sediment is being deposited. Okay. Now these features do have names. This on the outside bend, this is known as a river cliff, and on the inside bend, this is known as a river beach. So all you guys need to do is copy the diagrams from the first page here and add in the text below or annotate that in to explain what's happening. Feel free to put it into your own words if that's more useful, or you can copy and paste the images and then add in the text. And likewise for this diagram of the cross profile, be good to annotate that into your notes or copy and paste that into your Google Doc. Okay, now our next landform is oxbow lakes. And remember I said these are linked to meanders. And what an oxbow lake is it's a separate part of the river. So a lake, it's not joined anymore in a horseshoe shape, but it's been made by the meander. So as those meanders continue to bend, the neck of the meander, which is this area inside the bend, actually gets smaller and smaller and thinner due to erosion on the outside. And eventually what will happen, maybe during a storm or during high discharge, is the water will cut all the way through the neck. But when that happens, deposition switches from the inside bend and it blocks off the former channel. So we end up having this part of the meander, this head of the meander, as a separate channel to the main river. And this is, once it gets blocked off, this is now known as an oxbow lake. Okay, so again, if we could just add this third diagram to our notes, and we've got the text here to explain it. This is really just extra, so don't worry about making any notes on this page. But what happens is over maybe thousands or hundreds of years, depending on the energy of the river and the rock type, depending how quickly this happens, is the river channel actually changes shape quite a lot. So here we can see all of the scars which show us where the meander and the bends once occurred. So each one of these would have been a meander where the river was flowing, then it would have become an oxbow lake, then the river channel would have straightened, and that oxbow lake would have dried up and just left this scarred landscape. And this links in with our next landscape, which is floodplains. So these floodplains are actually formed by the river channel changing its course or its location. So a floodplain is just a wide area of flat land around the river. And as we said, it's formed as the river channel changes place. It's the area that when a river is in flood, when it's got a discharge which is more than the river can carry, this is the area of land that will flood. So again, what would be great is if you guys could just do a diagram of this into your books, please, or you can copy and paste the image and add in the text either as sentences or as annotations to that diagram, so that you've got the understanding in your notes. Again, this is just extra, but London is actually built in the Thames floodplain. Okay, the Thames Valley is the Thames floodplain. So if we think about the highland, which kind of we're up in Crystal Palace, and if we look across to Alexandra Palace in North London, all of that flat land on the other side of the Thames, where Central London, Westminster, Canary Wharf is built, that is all the Thames floodplain. And that's why we have to have embankments and the Thames barrier to try and reduce the risk of flooding all along the Thames. Okay. So your final landscape for our rivers and for today is levees. Now these are most prominent and only really apparent in the lower course. Levee is just a name for a pile of sediment that builds up on the banks of the river. Basically, when a river is in flood, when it comes out onto the floodplain, it loses energy because it's the channel which is efficient and where the water can flow fast. And as soon as it leaves that channel, it's much slower, there's more friction. So once a river is in flood, it can no longer carry its sediment, its load, and that's deposited on the floodplain. And the largest particles, the largest, biggest bits of sediment, biggest bits of rock and mud and sand, and the most is deposited nearest to the river. And that means over many floods, this pile of sediment will build up. And what it makes is natural flood defences, these natural raised banks that keep the river from flooding. Right? We actually sometimes build artificial levees, which are known as embankments, and London Embankment is named after the big concrete wall where the London Eye is built, and that is a flood defence to stop London Bridge and Waterloo and that part of the Thames from flooding. Okay, and just lastly here, any sediment that's been deposited by the river, so maybe on the sides here, or maybe when we think back to our meanders on the river beach or slip-off slope, is known as alluvium. Okay, it's really useful for humans because it's really fertile because of the kind of loose, soft mud and all of the nutrients that have been carried by the river. So for your final set of notes for today, if you could copy these diagrams or copy and paste the image into your notes and then annotate as the diagram has. If you want to add the kind of extra information, you're very, very welcome to. Now, hopefully that was easier for you to follow. Like I say, if you have any questions at all, please either post it on Google Classroom or post it on this YouTube video, and I'll do whatever I can to get back to you as soon as I can. Thanks very much.